Afternoon, everyone. My name's Vihangi, and I'm going to be talking about mobile app testing. Thanks for coming down and stopping by for this presentation, by the way. So, let's start with a question. How many of you have more than one device? Could be... Yeah, okay. So the most of the room. Do you remember a time when we did not have a device? We went from having a single device or no device to having multiple devices. We have so many applications, exactly. We have so many applications now that we don't even know what the number, I don't know at least. There might be some responsible people here, but I don't know. So the point is, the threat landscape has been changing over time. We were worried about vulnerabilities on web. Now we're also looking at malware spread through mobile applications or subscription scams, spyware such as Pegasus, or vulnerabilities such as the ones on Google, the Google Camera app or the Amazon Ring app. So today we're going to talk about how to identify these vulnerabilities. I don't have solutions for all of them, but we'll try to find some. Before we dive into that, here's a bit of introduction and a bit of a brag, but mostly introduction. So how did I get into pen testing, really? I was aspiring to be a developer, but did not enjoy really making code or building it, enjoyed breaking it. So here I am, 5 years down, work as a senior penetration tester at KPMG. If you're wondering what happened in those 5 years, connect with me on LinkedIn and we can chat more. While I get super stressed, one of my advice is to take a holiday. And during my holiday, that's what the picture of the moray eel is doing there. Nothing relevant to this presentation, by the way. Okay, so let's dive in. Today, I'm going to talk about what I normally do during a mobile app test. So we'll go through a bit of initial setup, look at some case studies, and the generate process. Any mobile app testers here, by the way? Okay, a few. So let's begin. What does your initial setup look like? So I have a Windows machine. And on top of that, I have a VM running Kali or Bexley. And then there are a set of tools. Let's begin with a very basic tool set for most web app testers. During this talk, we'll continue building our tool set, and by the end, hopefully we'll have something good enough to do mobile app testing. Okay, so the first thing, if you got an Android application, you could use the free open source Android emulator present on Android Studio. But if you're using testing for iOS apps, the scenario is a bit different. You see, there is the iOS simulator is not super useful. What you do have is either a physical device, which you can jailbreak. Please don't jailbreak your own device. That's not going to be good. Or you could use a platform like Corellium. But if you decide to go down the route of physically jailbreaking your physical device, here's what you're going to do. But let's see how it works. Now, when you turn on your iPhone, the first thing it does is it executes code from the boot ROM. The boot ROM contains the Apple root certificate and public key. Now that is used to verify the LLB. The LLB uses to validate the iBoot, kernel, and so on till the end. Now Apple was amazing and they were able to manage the hardware and software, and which is why we are able to see this process. There are also several jailbreaks available based on the version you want. But the interesting thing is, 3 out of 4 here, they are, so let's say checkra, they're all based on the same vulnerability. So that is checkmate. Now, checkmate vulnerability is present in the DFU mode, which is in the boot ROM. Well, the problem here was, even if you try to send a software update, it's not going to fix it, right? So Apple had to come up with a new chipset. one after A12, so A12 and after, you cannot use these jailbreaks. But there are multiple versions because based on the iOS version you have and the requirement, whether you want it tethered, non-tethered, and so on, you can choose that works for you. There's also an attempt, like Uncover. Some of you must have used that, but that was it was relying on the vulnerabilities on the operating system rather than vulnerabilities in the boot ROM. So now that we've seen how our initial setup looks like, our tool set is increasing. So we keep going. So now that we've learned what our setup looks like, let's try retrieve an application, decompile it, and see how that goes. So first, retrieve an application. Multiple ways to do that. You could use a third-party app store. If you're using Android, for Android, you can use APK Monk or APK Pure. If you're using iOS, the third-party app stores, third-party stores are quite limited. Or you could ask your client to give you the build, and that will make your life easier. To decompile this, what you'll observe is APK files or IPA files, they're just zip files. You can unzip it and you can see the structure. If you were testing an Android application, you could use different decompilers like APK Tool, JetX, and so on. If you're using iOS, you could use Ghidra or Hopper. These are some examples. I'm sure there are a lot more present there. If you're really lazy, you can also use MobSF. But like any other automated scanner, you don't want to rely on this. You want to use this as a starting reference point, and you want to use this, okay, these are the vulnerabilities that have been flagged, we can go manually check them. Okay, so we've seen a bit of static analysis. Now, this is how a toolset looks like. It's expanding, we're getting there. Okay, we've done this. Now, let's go to the easy stuff. Let's plug it in and actually load the application. How many of you have come across this error? Great. So, if your phone is rooted, then you should get this error while loading an application. It's basically a security mechanism to check whether your device is rooted or not. What do we do? There are some solutions. We could use an Android emulator, which we'll see in a second. We could write a custom script and hook the application with objection or Frida. We could use a non-rooted device. Not the best solution. Or we come back to this later. Let's look at the first scenario, which is using an emulator. For this instance, I'm using AndroGoat. Anyone come across that before? Okay. So AndroGoat is a publicly available application, and it has a lot of challenges, and I really recommend it for anyone who's trying to learn mobile app testing. So here, I used Android Studio, the emulator on that, and then I was able to bypass the normal root detection. But normally, there are checks for whether this is an emulator or not, too. In this scenario, obviously didn't pass it. So, for those who don't know what Frida or objection is, it's just a dynamic instrumentation tool that injects code so we can interact with the application. What you see on the screen here is I've hooked the application using objection, and I've listed a bunch of activities. Now, activities are just screens like your login screen or any screen. That's an activity. The most relevant activity here is the emulator detection activity. Okay, let's look at it further. So we've decompiled, and we're looking at the code snippet here. I've done the heavy lifting for you, so you're seeing the good part. Here, if you say this function is checking whether it's an emulator or not. Now we use objection to identify the class method for this activity. One of the class methods that we saw in the previous one was also isEmulator, and it returned a Boolean value. Now what that means is it will either return true or false, and by that I mean something like this. So if it's an emulator, it's going to return true. If it's not, it will return false. So currently it's returning true, correct? So what could you do to change this? Well, the answer is quite simple. Change the value to false. Now we are returning false to the function every time it calls this. And this is how we bypass the emulator. Well, that seems to work. So let's try something else. Now we're going to go on to looking at different case studies. Since we have seen some of the initial stuff, initial setup, and we walked through a bunch of that. Now we have a complete toolset. This is again a basic toolset. You obviously would expand as you keep going, but this is a good starting point. So the case study I'm going to be talking about is one of my favorite case studies because this was one of my first mobile app tests, and it happened a few years ago. But at the end, I was super happy. You'll see why. The first thing, it was rooted. It looked for root detection, like most applications. But the interesting thing was, it was using a third-party library called root beer. Anyone come across root beer? Okay, so, right. Now, if you Google root beer, you're going to find it. And what it does is, it uses this function to return whether the device is rooted or not. We could go back and use the same method that we used in the last slide, or we switch it up a little bit and write a Frida script. This Frida script is returning false every time we call this function, so you're able to bypass the checks. We hook the script via Frida, we run the script via Frida, and it should run. Okay, we've done this. What's next? We want to intercept the traffic, but they implemented another third-party library to stop this, and it uses certificate pinner to make sure that you cannot intercept the traffic. Well, we can go back and use the same method or change it up again. This time, we're going to use the scripts that are already present on objection. So I used Android SSL pinning disable, which is basically calling the same script, which is calling the script present on objection to disable it. Now, the thing to note here is the Frida code share is quite massive, so you can go on there and download the script and modify it based on what you want. You don't always have to spend time creating your own script. This saves a lot of time, especially on short engagements. Okay, so now we've done all the basic stuff. Let's look at the next bit. There were 3 endpoints that were identified. The first one, it requires a bearer token and some of the other parameters to give all the information about the current user. That is me in this case. But it also uses another endpoint to search for valid users. Now, it's using the phone number parameter to check whether the user exists. It returns an ID if the user exists and tells you whether the user is active. Now, the next one, we know the passcode is only 4 digits. This one uses the user ID from the previous one and uses a 4-digit passcode, which you use when you enter the application, to return all the information about the user which we saw in the first endpoint. If you're thinking what I'm thinking, we got to automate this and get all the users. Let's do it then. Well, obviously you don't want to do it manually, it's quite tedious. So, generate a list of random numbers, then use a Python library to validate whether these phone numbers are valid or not based on the country code. Then use the first endpoint to search for phone numbers and collect a list of valid user IDs. Hold on, there was a problem. There was rate limiting. But the rate limiting reset after every 30 seconds. So why don't we pace our requests? The next one, once we have a list of valid user IDs, we can now use that user ID and send it with brute force the password. If this all works, we should be able to create a database containing all the users possible. Well, that was fun. What was more fun was an unencrypted database that was lying on the phone once you load the application, just because we were able to bypass root detection. So during this case study, we went through bypassing some of the basic security mechanisms, looking at vulnerable mobile APIs. During the next case study, we'll look at another time where we found multiple vulnerable mobile APIs. Okay, so this is a banking application, as you can see. That's my user account. As any other banking application, I can transfer funds, add a beneficiary. I'm able to intercept requests. I can see my username. Now I can see my account number. And I can see a bearer token. These three things are required to make any request. Well, that all seems normal. Now, I have Anya's user account details. Well, I have an account number, which you would normally get if you're transferring money to anyone. Again, normal. What's interesting is, the last two digits of a username were only slightly different to mine, and what I'm trying to get at is the username was iterable. So if I found a valid account number and username, I could access other people's account. That's what I'm thinking, by the way. So let's try it out. So now I'm logged into my account and I want to transfer funds. I modify the request to change the username and account number to Anya's username and account number. Do you think that would work? Well, it did. Here is her account details while I'm logged into my account. Now, to transfer funds, there are two things. I need to be a beneficiary on her account, which I did by adding myself as one. And two, I should be able to access her account details, which I was able to. Now, let's go on transfer funds. Well, this would have been a very good Friday evening if it worked. But there was MFA checks enabled. But even better, you can disable it by making false. And I just got richer. That should pay for all my diving trips. So, now we were able to, in a scenario where this was possible on the application at that time, but if you look at it, the larger impact would be you could take over any user account and be able to transfer funds. The next case study is not going to be about vulnerable mobile APIs anymore. This time we're going to be talking about vulnerable Android components. So we're going to be using AndroGo, one of the challenges from there. So the challenge is bypass PIN verification. As any other tester, the first thing that comes to your mind, let's brute force, which I tried. Didn't seem to work. The error message did not give out anything. Super unhelpful. But there's another way to do it too. We decompile the application. Now, this time around, you can see the exported is set to true. Well, what does that mean? It means another application can read or call this Android component. But we're not going to be focusing on this. The task here is try to identify another Android component which can be exported. If you haven't spotted it yet, amazing, because we're going to walk through it now. So, first, let's make sure we're on the same activity. So we call the activity, and we know we are on access control issue activity. Yeah, that's the one. We look at the code snippet. What it's doing is verifying whether we have the right pin or not. Once it's verified whether we have the right pin, it's calling this activity. And you can see it's using an explicit intent to call this activity. Now let's go back to the manifest code. What you can see here is that activity has an implicit intent declared. Now, normally, exported is usually set to false by default, unless you specifically set it to true. But in this instance, since the activity has an intent filter declared, if you don't set it manually, by default, it's considered true. So now we know we can export this activity. Okay, let's go back. We know it's calling this activity. So why go through all the trouble of trying to find the pin? Here's what we do. We call the activity. And we've bypassed that. So now we can log in as a user without having to verify as a pin. In this scenario, we still had to bypass pin verification. But sometimes on applications, you can bypass the login screen or the password reset screen if some of the Android components were exported. To summarize, we went through the journey of how to conduct mobile app testing, or how I would, and hopefully this was helpful. And we saw some case studies of where this was possible and how it led to account takeover, PII disclosure, and also looked at some of the vulnerable Android components. Is there one solution? Not that I know of. There are multiple solutions for every little thing which we've seen here. But what we can take away from this is, if we can all be mobile app testers, and it's not that hard if you want to do it. Thank you.
Some questions?
Yeah. Any questions? Yeah.
Got any questions?
Thank you for the talk. I really appreciate the presentation. I wanted to ask if this is possible for, I guess, banking apps, or at least in your case, would it be possible to also spoof purchases? So if you were to get in-app purchases, would you be able to do something similar for this? And would it be possible now with Google Pay APIs, and would you be able to spoof is false, just like you did with the other apps, or MFA?
I mean, it's possible. I cannot comment about Google API side of things because I haven't tried it. But the reason why this was possible is because how the app was configured. When you call like other APIs, they're more securely configured. So if they were implemented in the application in a way that it was checking or calling, you could technically spoof it. Hopefully that answers your question. Any more?
Yeah. I can shout, it's not a problem. Thanks. We're pretty new to the mobile app development world. Where is a good resource for getting hold of the XML files around Android configuration of applications? As well as I know there's an alternative in iOS similar to XML inside of Android.
if you're looking for a methodology that you can create your own, or there are a few available online, but the MASVS, if you heard of that, it's a good guideline to know what you're looking for, right? And if you're looking for platforms, it's quite limited, but there has been a lot of research. So the Android Goat application or Insecure Bank, these are all like other applications which are present, which you can just test. And since it's all based on Android and you have an Android emulator, which is free and open source, you don't need the whole jazz to set up and all of that. You can just technically start testing there, and there are a bunch of challenges which help you progress and learn few of the things.
What challenge?
Yeah, sketch first.
Right. I wanted to ask about iOS because there wasn't much in that specification. I understand obviously iOS is pretty closed down, but with exploits like Checkmate, say if you've got an older device, since it's obviously I'd say hardware level, it's not so related to the operating system. Would it be possible to port operating systems like Linux to old iPads, for instance?
Sorry, to understand your question, you want to load Linux on an iPad?
I guess, or I don't know, would it be possible?
I think it's technically possible, as far as I know. Like, I know for MacBooks as well, you can partition it and you can load Windows while running Mac. So in this scenario, it's possible, yes. But it won't run iOS applications again.
Of course, but I was just saying, Checkmate, what potential solutions do you think there'd be apart from jailbreaking your iPad to jailbreak things? What other things do we have? I guess. What other things could you implement?
What other things could I implement instead of jailbreaking the device?
Yes, because since Checkmate's hardware level, could you essentially do anything with hardware?
I believe so, but I'm not entirely sure. So, So Checkmate is a vulnerability on the secure ROM, correct? And the main goal of this, you can do other things, right? This vulnerability was used by this jailbreak software for this particular purpose of jailbreaking, but as a vulnerability, you can use it for other stuff.
So it's not necessarily just
no, of course not. So the jailbreak software requires an exploit to perform a certain action, but the exploit itself can be used for multiple purposes.
Okay, thank you.
So I think some modern devices have hardware features like payment mechanisms and things where if you start messing with bootloader or similar, it flips a hardware fuse using it. And then methodologies for doing the type of testing you do that lets you access those features without killing them as part of the process.
I mean, it's kind of tough. I've bricked my phone a few times. But there's actually a large community, the XDR community, where you can find very specific methodologies on how to root your phone, especially for Android-based, whether it's a Samsung or whether it's a Pixel. And that, most of the times, if you follow that, and even if you get like a custom ROM like Lineage OS, it's usually fine. Yeah.
Thank you.
No worries.
Any others? Oh, I can certainly get them in today.
Thank you. So the question here would be, we talked about root bypass and emulator detection bypass. How does safety net and play integrity affect the methodologies? Is it also just a simple matter of hooking the function that checks play integrity status? Or is there some more integrated way that Google exposes for apps to check that isn't as easy to bypass?
So, I think they depend how they're implemented again. So there are different ways to bypass root detection and SSL pinning and all of that. And so if you disable hooking entirely for the application, you need to find a way to first bypass that. And then if the components are exposed, which comes to the point where whether you can access other parts of the application, yes. Only to the parts which are exposed, though.
I see. Thanks.
Cool. Any more questions? Cool. Common theme, you should get to it. Perhaps you guys need to cook up after the talk.
I wanted to ask, for beginners, someone who's not just looking to, I guess, read their own device, but someone who's looking to find and discover exploits, where would you, what literature, what sort of course and material would you recommend to them? Any certifications you want to get into the job search?
Well, I'm a big fan of SANS, but I don't want to be biased. There are a few certifications out there. Not many, but there's a lot of. It's still like quite a growing field. So if you want to look at, I can't remember that on the top of my head, but there is one certain place where it lists. It's like a mini checklist, which I'll come back at some point today and let you know. But there's a mini checklist of what you're supposed to look when you're testing Android and iOS. And again, going back to, you can use MASBS as a good starting point if you're looking for stuff. Sorry, what was the other part of your question?
I was just asking for, I guess, general literature reading material courses for, I guess, anyone to learn about exploits and discover themselves.
Right. Well, you're looking for, I would say the OS community is quite large, and you can keep an eye on that for any new vulnerabilities that are discovered and all of that.
And Via, are you going to be around this afternoon?
Yeah.
To be able to take questions?
Yeah.
So if anybody else has any questions, then please feel free to find V. And again, should we